Hey, hi everybody. Okay, in this video we have to see application of differential equations. Okay, we have to discuss in this chapter several applications of the theory of differential equations to geometry, physics, chemistry, mechanics, astronomy, etc. Okay, the first section of this unit is growth under decay. Okay, already we know that in physics students and chemistry students already we know that what is the growth and the decay. Okay, a chemical reaction of this type is called, what is this? A first order reaction. Okay, already we know that lot of this one. Here also we have to see growth and decay. Okay, let X be the number of decay of grams of matter present at a time t. Then minus dx by dt is equal to kx. Here k is greater than 0. Okay, we have to assume that this is an equation number 1. Since dx by dt is the rate growth of x. Okay, dx by dt is a rate growth. It is a rate growth, and minus dx by dt is the rate of decay. And the equation 1 says that the rate of decay of x is proportional to x, and the constant x is called the rate constant, and the constant x is called the, what is this, rate constant. Okay, this is on what is this, growth and decay. Growth is, what is this, simply it is an dx by dt. Okay, another decay is, what is this, minus dx by dt. It is depending on what is the sign also. Okay, first of all we have to see the problem. First problem is, if the population of the country doubles in 50 years, in how many years will it triple, under the assumption that the rate of increase is proportional to the number of inhabitants? Okay, this is a question. Read the question carefully twice or thrice. We have some ideas for that one. Okay, what is given? If the population, okay, again I have to read. If the population of the country doubles in 50 years, in how many years will it triple, under the assumption that the rate of increase is proportional to the number of inhabitants? Okay, we want to move on our solution. Let x denote the population at a time t years. Okay, generally we have to take this one. Let x denote the population at a time t years, and x naught to be the population of the time t equal to 0. T equal to 0. It is an initial condition. Okay, it is a growth method. Okay, it is a growing population is year wise it is growing. Therefore we are using, what is this, growth, rate of growth of x we have to consider. Okay, what is the first step? We have to assume that what is x denote the, what is this, population of time t years. Okay, in this is a general case, and x not be the population at a time t equal to 0. Okay, next we want to move on. Given dx by, it is a growth. Okay, the rate of growth. Okay, given dx by dt is equal to, what is this, kx, where k is the rate constant. Okay, already we know that k is the rate constant. Okay, just we have to simplify this one. How to simplify this one? Already we know that integration, how to solve the differentiation as well as the integration. Okay, we have to variable separable method. We are here we are using. Okay, x items we have to separate, and then constant items we have to separate. Okay, here we have two variables, x and t. Okay, x is depending on, what is this, time t. The population is depending on, what is this, it is time t. Then I write it is, what is this, therefore dx by x is equal to, what is this, k into dt. Okay, we have to integrate. We get log x is equal to k into, k is a constant, it is a rate constant. Okay, and the dt had to integrate, we get simply if it is t, plus we have one dx by x is log x. Automatically we are using the constant is also, what is this, log c. Okay, here we have to write it is in our ordinary integration we are using. Here in this integration, there is no upper and lower limits are given. Then how to write this one? Automatically we have to write what is this? We have to integrate. We have to write it as what is this? Plus c plus constant. Okay, dx by c integration is what is this? Log x equal to kt plus log c. Okay, log you have to separate log on one side and the remaining are on other side. Then automatically we get it is what is this? Log x minus log c is equal to kt. Log of x by c is equal to kt. X by c is equal to what is this? E power kt. Okay, then write it is what is this? X is equal to, okay, x equal to, I have to find x equal to c into e power kt. Okay, I have to find the value of x. X is equal to what is this? C into e power kt. Okay, in our what is this? The rate of growth. Okay. Okay, after time t is equal to 0. We are to taking initially at a time t is equal to 0. Okay, then at right it is what is this? At a time t is equal to 0. Automatically it is what is this? It is an initial value x equal to x naught. We have to substitute these two values in the above equation. X equal to x naught, we have to replace. We get it is what is this? X naught is equal to t equal to 0. E power 0, then we get it is what is this? 1. Then x naught is equal to c we get. Okay, I have to substitute x naught is equal to c, or c is equal to x naught in the above equation. We get it is what is this? X equal to x naught into e power kt. Initially we had to find what is this? X equal to x naught into e power k t. We had to find the value of c, and then we had to substitute the above equation. We get that one. Okay, I had to assume that this is equation number 1. Okay, at t is equal to 50. In our question also given at t is equal to 50. Okay, I have to see the question. If the population of the country doubles 50 years, okay, doubles the 50 years. Okay, it doubles the 50. The population is doubles the 50 years. Okay, then t is equal to what is this? Here it is 50. The population, we have to assume that the population is what is this? X. Doubles the 50 years. Then at right it is what is this? X is equal to 2x naught. Okay, hence 2x naught is equal to, I have to substitute that value. Again in our what is this? Given equation x. Okay, I have to substitute x is equal to c into e power kt. I have to substitute t equal to 50 and x is equal to 2x naught. Okay, x equal to what is this? 2x naught. Okay, I have to substitute, we get it is what is this? 2x naught into c into e power what is this? 50k. E power 50k. Okay, this is equation number 2. Okay, I have to substitute again c is equal to x naught. Okay, I have to substitute c is equal to x naught in equation number 2. We get 2 into x naught is equal to x naught into e power 50k. That x naught is cancelling. We get it is what is this? 2 into e power 50k. Okay, which implies e power 50k equal to what is this? 2. This is equation number 3. Okay, I take with this. Okay, what's our question? Okay, our question is what is this? In how many years will it triple under the assumption that the rate of increase is proportional to the number of inhabitants? And it is a question. Okay, triples. Okay, then I automatically have to find the value of what is this? When x is equal to 3x naught. Okay, I have to find the time t. Okay, to find t, okay, I have to substitute this value in x is equal to what is this? X naught into e power kt. Okay, x is equal to what is this? X naught in equation number 1. Okay, I have to substitute x is equal to what is this? 3x naught. Okay, x naught is cancelling. We get e power kt is equal to 3. Okay, for x is equal to 3x naught. Okay, e power kt is equal to 3. You have to keep it this. Okay, already in equation number 3 we have to find what is this? E power 50k is equal to 2. Okay, what's our aim? We have to find the time. Okay, we have to find the what is this? Time. Time means in how many years it is triple. Okay, it is a question. Okay, it doubles, we get it is 50 years is given. In triples means how many years. Okay, we have to find the time here. Okay, on that purpose we have to find the value of t. Okay, already in equation number 2, e power 50k is 2. Okay, here what is given? E power kt is equal to 3t. Okay, just we have to taking the powers of 50 on both sides. 3 power 50 is equal to e power 50k into t. Okay, e power 50k, the whole power t. Okay, already e power 50k is what is this? 2. Okay, I had to substitute equation number 3 here. Then we get it is 2 power t. Okay, 3 power 50 is equal to 2 power t. Okay, 3 power 50 is equal to 2t. What's our aim? We have to find the value of t. Okay, how many years we have to find? Okay, just we have to taking the logarithmic on both sides. We get 50 is equal to logarithmic principle. Log of a power b is, what is this? B into log a. Logarithmic rules. Okay, log of a power b is equal to b into log a. Here also we are using the same. Okay, then we get it is, what is this? 3 power 50 can be written as 50 into log 3 is equal to t into log 2. Okay, what's our aim? We have to find the value of t. Therefore, t equal to 50 log 3 divided by log 2. Okay, in our calculator, we have to find the value of log 3 and divided by log 2 into 50. We get an answer. It is approximately equal to 59 years. Okay, therefore, in 59 years, the population will become triple. Okay, this is our answer. In 59 years, the population will become, what is this? It is triple. Okay, next we want to move on the second equation, second problem. In a culture of bacteria, the rate of increase is proportional to the number of present. It is found that the number of doubles in 4 hours, how many may be expected at the end of 12 hours? Okay, here the time is given 12 hours, and then something if it is given, we have to find the how many times it is, what is this, how many times this is expected. Okay, it is a question. Okay, what is given? Okay, again we have to read the question. In a culture of bacteria, the rate of increase is proportional to the number present. Okay, it is automatically, it is, what is this? Growth decay. Okay, it is found that the number doubles in 4 hours, how many may be expected at the end of 12 hours? How many may be expected at the end of 12 hours? Okay, you want to move on the solution. Let x denote the number of bacteria at a time t hours. Okay, x denote the number of bacteria at a time t hours. Given dx by dt is equal to kx. Okay, dx by dt is equal to, what is this? Kx. And hence dx by x is equal to k into dt. Dx by x is equal to, what is this? K into dt. Okay, here also the same process of the last problem. Okay, just to write log x is equal to, what is this? Kt plus log c. Log x minus log c is equal to kt. Log of x by c is equal to kt. Therefore, x is equal to, what is this? C into e power kt. We have to keep it this. This is in our general one. Okay, we have to find initial and then next cases. Okay, then suppose x is equal to x naught at a time t is equal to 0. Here I had to substitute x is equal to x naught at a time t is equal to 0. Automatically we get it is, what is this? C is equal to x naught. I had to substitute c is equal to x naught here. Hence x is equal to x naught into e power kt. E power kt. Okay, in our question it is, what is given? It is found that the number of doubles in 4 hours. Okay, doubles in 4 hours is given. Automatically t is equal to doubles in 4 hours. Therefore, x is equal to t 2x naught, and then t is equal to, what is this? 4. I had to substitute that value in our above. In the above, we get it is, what is this? T equal to 4. We had to substitute, and at the same time I had to substitute x equal to 2x naught. Therefore, 2x naught is equal to x naught into e power 4. Okay, x naught is cancelling. We get e power 4 k is equal to 2. Okay, it's just enough. We have to keep it this one. We have to simplify this one. We get an answer. Okay, what's our question? How many may be expected at the end of the 12 hours is given. Here time t is given. We have to find how many times it is what is this? Expected. Okay, t is equal to 12. Okay, I have to substitute t equal to 12 in the equation number 1. Here equation 1 is not found. Hence x is equal to x naught into e power kt. I have to substitute here. Okay, I have to substitute t equal to 12. Okay, x is equal to x naught into e power 12k. Okay, x naught into, already we have e power 4k is 2. Okay, then 12k can be written as 4 into 3 is, it is 12. Okay, I tried x naught into e power 4k the whole cube. Okay, just you have to replace e power 4k is equal to 2 here, therefore x naught into 2 cube. Okay, 2 cube, you have to understand this one. E power 12k can be written as, what is this? 4 into 3. Therefore, e power 4k the whole cube. Therefore, x naught into 2 cube. This is equal to 8x naught. Therefore, x is equal to, what is this? 8x naught. Okay, how many times it is expected? Okay, in 12 hours, how many times it is original number? It is how many times? It is 8 times. Okay, therefore at the end of the 12 hours, 12 hours, there are 8 times the original number, which is enough. Okay, and the next we want to move on the third question. The number n of bacteria in a culture grew at the rate proportional to capital N. The value of N has initially 100 and increased to 322 in 1 hour. Okay, what was the value of N after 1 by 2? 1.5 hours. It is, what is this? Increased, it is given. Okay, increased means we are using, what is this? Growth, TK. Okay, here it is a solution the same problem. Here it is a dx by dt. In last problem also we are using dx by dt. In our problem it is automatically it is given the number of capital N bacteria. Okay, we have to write there is no x. Here we are using what is this n. dn by dt is equal to kn. Okay, dn by dt is equal to what is this? K into n. Okay, then I write x replaced by what is this? The last problem x is a bacteria, here n is a bacteria. Okay, then dn by n is equal to what is this? K into dt. Here also the same process of last one. Log n is equal to kt plus log c. Log n minus log c is equal to kt. Log of n by c is equal to kt. Therefore n by c is equal to taking exponential both side, we get n by c is equal to what is this? E power kt. We get n is equal to c into e power kt. This is equation number 1. You have to keep with us. Okay, what's our question? We have to move on our question. The number n of bacteria is the culture grow at the rate proportional to n. The value of n was initially 100. Here it is given. Initially 100 is given. Okay, automatically I write the time goes to this 0. It is initially, it is given initially. Therefore, the time goes to this 0, t equal to 0. When t equal to 0, okay, n, capital N is, what is this? 100. So that I substitute the equation 1, n is equal to 100 and t is equal to 0, we get e power 0. E power 0 is, what is this? It is 1. Okay, and then I substitute n is equal to 0, we get automatically c is equal to 100. Okay, substitute the value of equation 1, c is equal to 0, therefore capital N is equal to 100 into e power kt. Okay, this is equation number 2. I take it with this. Okay, and then we want to move on our question. And increased to 322 in 1 hour. Okay, what is the question? And increased to 322 in 1 hour. What was the value of n after 1 by 2? 1.5 hours. It is a question. Okay, and increased. What is the question? And increased. Okay, and increased to 322 in 1 hour. Okay, then I write n is equal to what is this? 332 when 1 hour is given. When time is, what is this? It is t equal to what is this? 1. Therefore, 3, I had to substitute in equation number 2. Automatically we get it is, what is this? 332 is equal to 100 into e power k. T equal to 1, I had to substitute. Okay, therefore k equal to what is this? Okay, taking log on both sides, we get it is, what is this? K equal to log of 3.32. Okay, here I tried 100 just to simplify, e power k is equal to 3.32. Okay, taking log, we get it is, what is this? K equal to log of 3.32. Okay, I keep this. Okay, already we know that. What is the question? What was the value of n after 1.5 hours? Okay, 1.5 hours can be written as, what is this? T equal to 1.5. Okay, what's our aim? We have to find the value of n. Okay, then n is equal to, or substitute again in equation number 2, n is equal to 100 into e power, okay, what is this? K value also I had to find the last step, log of 3.32. I had to substitute this one, 3.32 into t is 1.5. Okay, log of 3.32 is separately into, what is this? 1.5. Again the next step I write this one, 100 is equal to e power 1.5 into log of 3.32. Okay, already we know that the logarithmic principle, a into log b can be written as log of b power a. Okay, here also we are using that logarithmic principle. We are tried 100 into e power log of 3.32 the whole power 1.5. Okay, e and log is cancelling. Okay, already we know that exponential and logarithmic terms are cancelling. We get it as what is this 3.3 to the whole power 1.5. Therefore, we get 100 into 3.3 to the whole power 1.5 can be written as it is 1.5 hours can be written as 3 by 2. Okay, already we know that this one mixed fraction can be replaced by what is this fraction 3 by 2. Okay, I will simplify 3.32. How to write this one? 3.32 into 3.32 the whole power 1 by 2. Okay, I will simplify this one. We get it as what is this? N is equal to 605. Okay, the value of n we have to find. What is this? We found that what is this? N is equal to 605, which is enough. And the next problem is a tank contains 100 liters of fresh water. Salt water, which contains 2 grams of salt per liter, flows into the tank at the rate of 2 liters per minute. Okay, the mixture runs out at the same rate. How long will it take for the quantity of salt in the tank to increase from 50 to 100 grams? Okay, what is given? 100 liter of fresh water in our tank. Okay, salt water which contains 2 grams of salt per liter flows into the tank at the rate of 2 liters per minute. The mixer runs out at the same rate. How long will it take for the quantity of salt in the tank to increase from 50 to 100 grams? Okay, solution. Let X denote the number of grams of salt in the tank at a time t. Okay, generally we have to take this one. We have to taking this one. Okay, and now during the interval at 2t, okay, 2t liters, okay, 2 into dt liters, there's salt water flows into the tank. Therefore, the amount of salt that flows into the tank in the time dt is 4 into dt. Okay, 4 into dt grams. This water that runs out of the tank in the interval dt is also 2 dt liters. Amount of salt leaving the tank is x by 100 into 2 dt. Therefore, if dx denote the change of the amount of salt in the tank during the interval dt, then dx is equal to what is this? 4 dt minus x by 50. Okay, x by 100 into 2t. I had to simplify this one. We get it as x by 50 into dt. Okay, 50 dx. Just after taking the LCM, we get 50. Okay, cross multiplication, we are using this one. 50 dx is equal to what is this? 4 into 50 is 200. 200 dt minus x dt. Okay, I have to simplify. I have to taking common outside by dt in this right hand side. We get to 200 minus x into dt. The 450 into dx by here also we are using the variable separable method. 50 into dx by 200 minus x equal to dt. Okay, I had to simplify this one. I had integrating on both sides. Okay, dx by x integration is what is this? Log x. Here it is what is given, dx by 200 minus x. In front of x we have a negative sign. Therefore, how to integrate this one? Already we have 50. I keep it as 50. Log of what is this? 200 minus x. It is negative or that. Then I write how to write this one? Minus 50 log of 200 minus x. This is equal to, just trying to integrate dt also. We get it is what is this? T plus c. Okay, initially when t is equal to 0, x equal to 0. Okay, I had to substitute t is equal to 0, x equal to 0. T equal to 0 means it is c alone in this right hand side. X equal to 0, I had to substitute what is this? Minus 50 log 200. Okay, I had to find the value of c also. I had to substitute in c the above equation. Okay, therefore minus 50 log of 200 minus x equal to t minus 50 log 200. Okay, therefore t equal to what is this? 50 into, okay, I'd write log on one side. Therefore t is equal to minus 50 log 200 goes to, we get it is what is this? 50 plus 50 log 200. Okay, already we know that log a minus log b is what is this? Log a by b. Automatically we get it is what is this? 50 is common. I had to keep it this common. Okay, t equal to 50 into log of 200 divided by 200 minus x. when t equal to 50, in our question is given t equal to 50 and then t equal to, it is lies between. In our question is what is given, okay, how long will it take for the quantity of salt in the tank to increase from 50 to 100 grams. Okay, first you have to substitute x is equal to 50 and then x is equal to 100. Okay, I have to substitute x is equal to 50 here, 200 minus 150. Okay, I have to simplify this one, 50 into log of 4 by 3. T1 is equal to, what is this, 50 into log of 4 by 3, and when x is equal to 100 you have to substitute, we get it is, what is this, T2 is equal to 50 into log 2 simply. Okay, therefore the time for the quantity of the salt to increase from 50 to 100 grams is T2, difference is increasing. Okay, when increasing is given, therefore 100 minus 50. Okay, automatically T2 minus T1, therefore 50 into log 2 minus log of 4 by 3. Already we know that again, log A minus B, log A minus log B can be written as log of A by B. Okay, then alright, you have to simplify this one, T2 minus T1 is 50 into log 2 divided by 4 by 3. 3 you have to simplify, 3 goes to, what is this, numerator, therefore 2 is cancelling, 1 2 is cancelling, we get it as, what is this, 50 into log of 3 by 2 minutes. Okay, therefore we get it is, what is this, T2 minus T1 is equal to 50 into log of 3 by 2 minutes. Okay, increasing in 50 to 100 grams, you get that answer, 50 into log of 3 by 2 minutes. Okay, these are the exercise problems. You have to work out this one. Here also the similar way of the last 4 or 5 problems. Okay, which is enough. The first section is over for the applications of differential equations, growth and decay. Okay, thank you.